I just want to go over this for the online students and for y'all. The assignment today is going to be a quiz grade. I just want to go over some of the questions real quick and kind of give you an idea. Close your Chromebook. I know you already did it, but you should have done it early. Why don't you wait till class to do it? So I'm going to go over some of the questions, not all of them, but just a couple because I want to kind of reiterate how you get to that answer. I want to show you that on these unit quizzes, you can use the previous quizzes. So this is over the unit. Actually, let me get my pen that I can move stuff here. Oh, I got it. No, I don't do this. What's even happening? So we're doing this unit assessment. When we do these quizzes, I make some of your other assignments quiz grades just because we got to have more quiz grades than these. But these unit assessments are what I use to help build the tests. And all the questions from these unit assessments come from the other practice assessments. So this unit, Exploring the Universe, has 3 different sections. And I talk about this on the Google Classroom post that I made today. You have a practice assessment for understanding the universe. You have a practice assessment for stars and galaxies. And you also have a practice assessment for technology and the electromagnetic spectrum. So all the questions you see on this unit test, you've already seen in these 3 practice assessments, and you can go back and look at your results to see kind of how you did and what the questions are. You may not want to spend that much time finding each of the questions, but they are there, especially if you have one that you're like, I don't know this one. Hopefully you know most of them. But real quick, I just want to go through some of the questions. You should know what a galaxy is. You've had this question a couple times, so you should know about the island universes.
On the first one, it's like, what is a galaxy? But isn't a galaxy like billions of stars and dust and everything?
I mean, there's gonna be dust in there, but it's really more just about the stars. That's what we're looking for. It's really more just about the stars. For the island universes, you're looking for something that kind of describes why we would call it an island universe, but it's not. It doesn't resemble an island, and the real reason that it's not going to be this one is because it's not extremely dense. You do have stars. Hey, get out of the way. You do have stars, but there are no super dense parts of a galaxy. Even in a galaxy, the stars are spaced very, very, very far apart. It's just they're so far away from us, and they're kind of clustered together that they look all in one place to us. Let's see. Relationship between supernova and star formation. This one. Star A has a mass 20 times that of the sun, while star B is a low mass star. Based on this information, which happens, what you're looking for here, the big stars will go supernova and turn into either a black hole or I forget the other thing. But basically, it will turn into a supernova. Star B will end up going to a red dwarf. It will get bigger, just like our star. Oh, my poster fell down. Just like our sun will turn into a red dwarf, and then it will eventually shrink down, or not a red dwarf, a red giant, and then it will eventually shrink down into a white dwarf. So know that what they're talking about here is their sizes and what they're going to do towards the end of their life cycle, which is in the stars and galaxies section. Let's see. How are galaxies classified? I think you should know that. We went through 3 different names for the types of galaxies. One of them, the Milky Way galaxy, is what type of galaxy? Spiral. Yeah, so that should give you a big clue. Which of the following statements is true about electromagnetic radiation as white light? We all know what white light is and why there's all sorts of different types of it. Let's see. The gravity one I want to talk about. They give you that. You might have to look up the electromagnetic spectrum to answer this correctly because they're comparing microwaves versus ultraviolet. So you might want to look and see what part of the spectrum they are on. Optical telescopes. Oh, we had this recently. Why do we launch them into space? So let me come down here because they talk about that. Scientists once hypothesized that the universe has always existed in current state with a constant average density. Does the Big Bang theory support this hypothesis? No. Constant and its current state. The Big Bang theory talks about things changing. Everything's expanding. You had a huge eruption of matter and space and time. And so it's not going to be the yes answer on this one. Where's the gravity one? We're almost here. Here we go. Okay. Two asteroids, asteroid A1, and A2 are located 100 kilometers apart. The asteroids have identical masses that attract each other with a gravitational force of F. Upon colliding with another asteroid, A1 loses half of its mass, and the collision also knocks A1 100 kilometers from A2. So they started off 100 kilometers, and it makes it another 100 kilometers, so it doubles the space. So what I want to go over real quick, because I think I talked about this before, but I'm going to be honest, I don't know that I did the greatest job kind of illustrating this. Gravity, and I realized this while I was grading my dual credit grades. Gravity is due to mass and the inverse of the distance squared. So you have mass, and then if it's inverse, you're going to have distance on the bottom, and it's going to be squared. So this is actually, to be honest, I don't know if this is the exact formula, but this is what we're using for space type interactions. So if we take half of the mass, it knocked half of its mass off, right? So half of its gravity is actually gone away. So this is how much it's going to change. If you just have G as the main gravity, we're going to take half of that, and then the distance gets what? But it does, yeah, it's a factor of 2, so it gets doubled, right? So our distance here, we're not going to use the 200. We're just comparing it to the original gravity. So it's going to be 1 over 2 squared. What's 1 over 2 squared? 1 over 4. So you're actually going to have 1 over 4 here, and we're multiplying these together. So 1/2 times 1/4. Basically, what is 1/4 of 1/2? That's going to be the answer that you're looking for there. I'm not going to give you the answer, but you're not adding these together. It's not 1/2 plus 1/4. It's 1/2 times 1/4 to help you get to the gravity. So that's how they got to that answer there. Hopefully that helps some of the online people. And I think that's it. I just really wanted to go over those couple questions. Make sure that if you have questions, consult your previous assignments that you use. And if you need any help, let me know. Yay. All right. And online people, if you have any questions, please send me an email. I will be here all day. Thanks, and see y'all tomorrow. Tomorrow we'll start on a new section, so we'll probably just do lecture tomorrow, no assignment.